Hello students, welcome to first episode of force. In this chapter, we will learn the meaning of movement of force with its various application, and then we'll go for equilibrium, kinds of equilibrium, the principle of movement. Then we end the lecture with the numericals related with the same topic. So let's start the lecture. So let's start the topic with some important concept. First, you should know the meaning of rigid body. So what is actually the rigid body? That does not get deformed even under the action of the number of forces applied on that body. If the body does not get deformed, then the body is called rigid body. So in day-to-day life, the rigid body that you can experience, that the stone is the rigid body, wood is the glass, metal, all are the rigid body. Actually 100% rigid body is not possible. So they are just a rigid body that we can consider uh, not pure 100% rigid body, but we can consider this as a rigid body. So for to know the meaning of this chapter, we should know the two types of motion that you have to discuss in this chapter. The one is translational motion. Translational motion means what happen if you apply a force on this body which is free to move. Definitely when you apply the force on this body, then the body will go in a direction of force if the body is free to move. Okay, suppose this is a body A, you have applied a force on this body, then what will happen? Since it is free to move and you have applied the force on that body, then what will happen? It will move in a direction of the force applied. In which direction the force is applied, the body will go on that direction. That type of motion that generally take place in a straight line, that type of motion is what called your translational motion. So sometime it is also called linear motion, because here the body start moving in a straight path. Here the one important thing is that the body is free to move. Okay, now comes rotational motion. So rotational motion, here also the body is moving, but actually here the condition is that the body is fixed with some things. Like suppose if body is pivoted, here the body is pivoted at a point, it is fixed at particular point, with the particular point it is not free to move. So suppose this is the body, this is the pivoted point, means the axis of rotation. The axis of rotation, what happen if you apply force to this body? The body will not go for a straight to cover a straight path. Actually it will rotate about its axis only. So in that case the body will not cover a straight path, it rotates the body passing through its axis about its only the pivoted point. So that type of motion is called rotational motion. Here the body is not free to move. So the example of rotational motion that you can see in your day-to-day life, you can observe at your home also. When you open or close the door, what happen? So the door is pivoted at a fixed point, that is what called hinges, its axis of rotation. So when you open or close the door shows the rotational motion. It covers the rotational motion, not the translational motion, because door is not free to move. It rotates around around its axis only, not go covers a straight or linear path. So to know the concept of movement of force, first you should know the meaning of what is point of action of force. In exam, they will never ask you what is point of action of force, but you should know what is the point of action of force to make your concepts more clear. So, suppose this is a rigid body, okay? This is a rigid body. So, the point on a rigid body where the force acts. So, suppose this is a point on the rigid body, here the force acts. Okay, here the force acts. Suppose this is a point, here the force acts. So, this point is called point of action of force. Okay, here the force acts. Okay. Now the line of action of force. Suppose this is a rigid body. Suppose this is a rigid body. Here it is the point of action of force. So the imaginary line drawn in a direction of force that passes along with the point of action of force. That imaginary line is what called line of action of force. So the line, simple, the line that imaginary line that passes with the point of action of force. The point of action of force, the point where you have applied the force on the rigid body. And that point of action of force can be transmitted anywhere along the line of action of force. So, meaning suppose this point is what called the point of action of force. Here the force F is applied. This line is called line of action of force. Okay, and this point is called what? Point of action of force. Point of action of force. This point can be transmitted. That is the concept, that this point can be transmitted anywhere along the line of action of force. That we will see in various examples how it can be possible. Movement of force, that is also called torque. So what is movement of force and why we are studying this movement of force? We are studying movement of force because any turning effect on the body is just due to the movement of force only. If you know the reason, the cause behind the turning of the body, behind the rotational motion of the body, then you should know the meaning of movement of force. So let's see how we calculate the movement of force, because that comes under the rotational motion part. So we know that in rotational motion, if we consider this is a rigid body and that point is what called your axis of rotation, if this is the pivoted point or your axis of rotation, okay, so in order to calculate your movement of force, you should know the first you have to apply the force. Okay, so if suppose at point A you have applied the force, okay, so that is what your point of action of force. So, and we know that the point of action and the imaginary line drawn in the direction of the point of action of force, that is what called your line of action. So, the dotted line, this is your line of action of force, okay, and this point is called point of action of force, and that point of action of force can be transmitted all over here, the line of action of force. So B is also the point of action of force. If we draw a perpendicular distance from the pivoted point to the line of action of force, that we have to measure that perpendicular distance and the magnitude of force that we have applied over here. The magnitude of force that we have applied over here. So if we do the product of how can we calculate movement of force? moment of force, we have applied a force on this rigid body, right? So the magnitude of the force applied into the perpendicular distance, from where to where? The perpendicular distance from the pivoted point, the perpendicular distance between the pivoted point and the line of action of the force. Okay, so that is what the line of action of the force, where your the force is applied, that distance, the product of these two gives you the moment of force. So let's see what says according to definition. It is equal to the product of the force, product of the magnitude of the force and the perpendicular distance of line of action of force from the axis of rotation. The perpendicular distance from the line of force to the axis of rotation. This is our axis of rotation. So that the product is called moment of force. If we know, and the moment of force is also called torque. Okay, so if we want to find the unit, the SI unit for the moment of force, then we can calculate the force. The unit is Newton, and OB is what? The distance, and for distance the unit is meter. So the SI unit of moment of force will be Newton meter, and the CGS unit will be for force. The CGS unit is dyne. So dyne centimeter is the CGS unit. So factors on which the moment of force depend. Moment of force depends on two things. One is the magnitude of the force applied, and the other is perpendicular distance of the line of action, of force from the axis of rotation. So if we consider this is a rigid body, so if this is your pivoted point. Okay, this is your pivoted point. So if I apply, this is the point of action of force. This is a point, A is the point of action of force. This is your what? The line of action of force. So the perpendicular distance, this is the force that you have applied. So this is the perpendicular distance from the perpendicular distance of the line of action of force from the axis of rotation. So let it be O. So the moment of force that we can calculate by product of this and this OP. Okay, the moment of force that can be calculate by the moment of force or torque can be expressed by this letter. So that can be force into the perpendicular distance. So the moment of force depend on the two things, force and the perpendicular distance. Don't tell only the perpendicular distance of the line of action of force from the axis of rotation. This perpendicular distance is what? Between the line of action of force from the axis of rotation. That is the perpendicular distance. Okay. So when a body moves in a rotational motion, there are two kind of movement, the clockwise movement or anti-clockwise movement. Since your body is restricted to go in a straight path, so either it can move like clockwise or anti-clockwise. What do you mean by clockwise or anti-clockwise? If your movement is according to what the clock moves, okay, then the movement is clockwise movement. So generally the clockwise movement, that is like this way. Okay, if that your clock, the hand of your clock moves, that is what called clockwise movement, and anti-clockwise movement just opposite to that, what your hand of the clock moves, that is what called anti-clockwise movement. Whenever you have shown some movements clockwise or anti-clockwise, so you just have to show the sign. actually there is no way, but conventionally we just take a sign positive or negative for clockwise or anti-clockwise movement. So for clockwise movement, sometimes it is very difficult to memorize because there is no hard and fast rule to say it is positive or it is negative or it is negative or it is positive. So I am giving you a trick so that you can memorize that which one is clockwise, which one is positive and which one is negative. So just memorize the letter in your chemistry, that is CN, cyanide. You know that cyanide, okay? So just memorize this word cyanide. CN is symbol for cyanide. So CN, so CN means here you can learn clockwise, negative. So whenever there is a clockwise movement, you have to consider it negative, and any anti-clockwise movement you have to consider it as positive. So that is what our convention only. Now let's start the applications of moment of force. So, to know the various application of moment of force, just let us take very small example, even that you can see in your day-to-day life, that what I have drawn. So, this is what your seesaw. Okay, so that is what your that point is what your axis of rotation or the pivoted point. Okay, pivoted point or the axis of rotation. Okay, so here what you have seen, that the two things get balanced or in equilibrium. Here the child which is sit here, that is the of heavy weight, or big child, suppose that has heavy weight, and this child is of light weight. But if I need to balance both of them, then how can I balance the situation in a seesaw? So if I just place the light weighted child at a larger distance from the pivoted point, okay, larger distance from the pivoted point, and the heavy one placed at a smaller distance from the pivoted point, then the two can I make the balance, because here in that case the moment of force becomes equal, because we know that the moment of force depends on two things. One is the force applied, and the other thing is the perpendicular distance from the pivoted point. So if you want to make the moment of force from this side and this side to be equal, then your moment of force depend on what thing? The moment of force depends on the force and the perpendicular distance, right? So if the value of force is very less, means this child is very light weighted, means the force applied by him is very less. So if you make this distance larger, then if this value is less, and if you make this value larger, then your value of force of movement go up. And if the force is large, if force is large, the weight is heavy, the force is large on this side. So if this value is more, you can make this value less, so that the force of movement on the both side comes in equilibrium position. So from this example, what you have learned, that if the larger distance, by making the body, by placing the body at larger distance from the pivoted point, we just have to apply very less force. So what we have learned from this example, that this is very important line that I have written, that small force can produce large moment of force. The small body or small force can produce a large moment of force if it is kept at larger distance from the pivoted point. By keeping the body at the larger distance from the pivoted point, even the small force can produce large moment of force. So that the concept that what I am going to teach from this example, that line is the important thing what you have learned from this example. So another example that we can see in our day-to-day life, that when we open the door or close the door, just we have seen that where the handle is situated, with that you can, with the help of that handle you can open the door. So here also, suppose I have taken, this is a door, so that is the pivoted point or hinges from the, that gives the axis of rotation of the door. So these are the 3 points A, B and C. So if you see, the point A is at the larger distance from the hinges, from the axis of rotation. This is what your axis of rotation. Okay, this is what your axis of rotation. So what you can see, that the point A is at the larger distance from the axis of rotation. B is little bit smaller distance from the axis of rotation, and the C point here is on the axis of rotation. So if you want to rotate your door, moment of force, so the moment of force depends on the force and the perpendicular distance, right? So at point A, if you see here, since the distance, perpendicular distance is large, so even point A, if you open the door from if you open the door from point A, then even the small force can produce the large moment of force. Why? Because here, even if we apply the small force, then since it is placed at the larger distance from the hinges, from the axis of rotation, so here at this point, even if you apply very small force, then that can produce larger moment of force, and you can open the door very easily. So if you apply the if you open the door by keeping your hand over this point, then since the perpendicular distance become lesser, so to produce large moment of force, you have to apply very large force from here. And if you apply the if you want to open the door by through the point C, then you will not able to open the door, however the large force may be, because at this point your the perpendicular distance will become 0. So you are just at the axis of rotation, on the axis of, at the point of the axis of rotation, so your this force becomes 0. So however this force may be, your the moment of force value will become 0, means your door will not open. So we have seen two examples, two application of moment of force in our day-to-day life. First was the seesaw, and the second was how you can open or close the door. So there are a few more examples that is related with the application of the moment of force, even that can come in your exam in form of reasoning. So I have taken a few. So definitely all of them depends on the movement of the force. So what we have to produce here, the large movement of force. So the large movement of force can be produced by two ways. First, by applying the large force, okay, and the second by keeping the object at a larger distance from the axis of rotation. So which thing is best for you? Would you like to apply more force on the body to do the same work, or you will keep the body at a larger distance from the axis of rotation? Yeah, definitely the second thing you will prefer, to apply the force on the body, keep at a larger distance from the axis of rotation. Okay, so that the two things that we can do. So let's see the few example and try to answer those questions. That upper circular stone of a hand floor grinder is provided with a handle near its rim. So why the handle is provided near its rim? So here the handle is provided. So this is what your axis of rotation. So axis of rotation. So if the handle is provided here, so if that is at a larger distance from the axis of rotation, so even the small force, if you apply here even the small force, then it can produce large moment of force, because that is at the maximum distance from the axis of rotation. So if it is asked in the exam, that only just have to write the answer, that since if the handle is provided at the rim, then it is at the larger distance from the axis of rotation. So even the small force can produce large moment of force. Similarly, to turn the steering wheel, a force is applied tangentially on the rim of the wheel. Why? So if this is the steering wheel of your car, this is what the axis of rotation. So from where you apply the force to make the wheel rotate. So definitely you just apply either the clockwise or anti-clockwise, whatever the force you applied, but you apply the force tangentially on the rim of the wheel. Why? Because that distance is at the maximum that point is at the maximum distance from the axis of rotation. So if you apply very less force, that produce large moment of force. Here also spanner, the spanner is a device that is used to tighten or loosen a nut. So why they have the long handle? So if the handle is long, then it is from the larger distance from the axis of rotation. So from where you are applying the force, that would be at the larger distance from the axis of rotation. So if you apply very less force, it produces large moment of force, and you can easily tighten or loosen your nut by even applying a small force from that part of the handle. Couple. So what is couple? So suppose this is your rigid body. Now this is the line of action, and you have applied the force here. This may be the point of action of force, and this is the line of action of force. Suppose, don't think about this thing right now. This is your line of action of force, and this is what your pivoted point. So what I have told you, the moment of force will be, if you want to rotate this body, the moment of force will be what? The force into what? The perpendicular distance of the line of action of force from the axis of rotation. That what I have told you. So that is what the moment of force on this line. This is the one line of action. Okay. So now if you see here, that is the another force is of same magnitude but of opposite direction and having different line of action. So if I want the moment of force from here, so what is that? Force into what? The perpendicular distance from the axis of rotation, that is what? OB. The perpendicular distance from the axis of rotation, the OB. So now if you combine both of them, why actually we are just combining? First you should know that idea. If you want the greater moment of force, that's why we are just combining two. So if we want the greater strength of the moment of force, more of moment of force, so then we need to combine both of them. So then when we combine both of them, na, the moment of force from this side and moment of force from this side, then they form a couple. But the important criteria for this is the two force acts on the same body with the same magnitude and different direction with a different line of action. What is the condition to form a couple? The two equal and opposite forces acts on the same body on different line of action. Okay? Then they form a couple. If we combine the moment of force of the both, then it form a couple. So I am going to combine this. So couple will be, if I just add these two, what I get? If I take F common, then what I get? OA plus OB. That I can write AB. So the couple is what? The force, either this force or this force, either force into the AB. AB is also called the arm of couple. Arm of couple. So that is what the formula for the couple movement of couple of forces, or this is the definition, that is the formula. Okay, and this is the definition. The two equal and opposite forces, acting on this rigid body such that they act along different line of action, their line of action different, forms a couple. So this is the couple, and the formula unit of the couple is same as that of moment of force. So couple is nothing, couple is nothing but the moment, the combination of the moment of the forces, that is called moment of couple. So when I had explained you the meaning of the moment of force, then I gave you the concept only the moment of force is what? The force into the perpendicular distance. So here in that case also, na, your couple will come into picture. Then why we are not considering it? Here also you will see the two kind of force acts here. The one, the external force that you have applied on the rigid body, that is what your external force or action force. When you apply the force on the body, force on this body, then this pivoted point also produce the reaction force. There is a force, the reaction force, that is produced by the pivoted point, then which is equal and opposite in magnitude of the external force applied. Then why we don't consider this? Because if we are calculating the moment of force due to the action force, that is force into perpendicular distance, the moment of force due to the reaction force is what? Force, reaction force into perpendicular distance. But since this force acts on the pivoted point on the axis of rotation, for this force the perpendicular distance is 0. That's why we just neglect this force and we just consider this force also. Otherwise, whenever there is a rotational motion and the body rotates, the both force comes into picture and they forms a couple. So I think now you have understood the meaning of the couple. That couple that acts on the same rigid body, when two equal and opposite force acts on the body with a different line of action, then it forms a couple. The product of the either force and the arm of the couple gives you the magnitude of the movement of couple. So here are the few examples that can be asked in your exam, that give example of couple. So opening or closing of the tap, water tap, that you need to apply the equal and opposite forces. So whenever there is you need to produce any turning effect now, then couple comes into picture. So that is an example, opening and closing of the water tap. Here equal and opposite force comes into picture, turning a screwdriver, winding the watch with the key, okay, tightening the cap of the ink, tightening or loosening the cap of the ink bottle or any kind of bottle, that just to produce the rotational motion or the turning the key in a lock, just apply the couple. That is example of turning the steering wheel. So here are the few examples where you find the use of the couple. So what is equilibrium? So definition of equilibrium says when the number of force acts on a rigid body such that it does not change its state of rest or uniform motion, the rigid body is said to be in equilibrium. So when the number of forces applied on the body, the number of forces applied on the body from various sides, but the body does not change its position of rest, or if the body is moving, then it maintain its that motion only. Body does not change its position of rest or motion, then that rigid body is said to be in state of equilibrium. So kinds of equilibrium: two types of equilibrium, static equilibrium and dynamic equilibrium. So what is static equilibrium? In spite of so many forces acting on a body, if the body maintains its state of rest, if the body maintains its state of rest, it remains in state of rest in spite of several forces acting on a body, then the body is said to be in static equilibrium. Let's take example. So suppose a block is placed on the ground, okay, block is placed on the ground. So if the force is applied, on the block, okay, but block will maintain its position of rest. Why? Because if the force is applied on the block from the opposite side, the frictional force, the equal frictional force that is exerted on opposite direction, that of block, that will cancel out that force, and also the weight of the body block here, the balanced by the reaction force, okay, that is the reaction force on the body. So here, in spite of the various force, the body will maintain its state of rest. The other is dynamic equilibrium. So in spite of the various force, if the body maintain its position, uniform state of motion, then the equilibrium is said to be in dynamic equilibrium. So here the force applied is balanced by the force of friction. That's why the body does not change its position of rest. So here are the few examples. If the train or the aeroplane is moving with a constant speed, so here the force applied by the engine of the train or the plane, that is balanced by the frictional force of the air. That's why the body will maintain here the uniform state of motion. So that's why we can say the moving train with a constant speed and the moving aeroplane with a constant speed in a state of dynamic equilibrium. Principle of movement. So what is principle of movement? If the number of forces acting on a rigid body, suppose this is I have given example. So this is a rigid body, and the number of forces acting on a rigid body keep it in equilibrium. Okay. So this F is what your the point of the equilibrium. So if you see from point F, then the sum total of the clockwise movement, the sum total of the clockwise movement about the turning point. So this F is what your turning point. So here if you see the anti-clockwise movements, so due to the force F1, due to the force F2, and the clockwise movement due to the force F3. So here what the principle of movement says, if the body is in equilibrium, then the sum total of the clockwise movement is equal to the sum total of the anti-clockwise movement. So how do we calculate the sum total of the clockwise movement? So clockwise movement is what? Movement is what just we have studied now. So how do we calculate movement? The force into the applied force into the perpendicular distance from the axis of rotation, right? So for here, for this body, the force is F3 and the perpendicular distance from the axis of rotation. So this is what your axis of rotation. So that is what the perpendicular distance, right? That is what the C. So F3 into C, that is the clockwise movement. Anti-clockwise movement. Anti-clockwise movement is what? The force due to F1. So force due to F1 into the perpendicular distance. So what is the perpendicular distance from that of this point from the axis of rotation? This is A, plus the other force, the two force is on the side of clockwise. So that is what? Sorry, anti-clockwise, that is F2 into the perpendicular distance for the force F2 is what? B. So that is what? The anti-clockwise movement. What according to principle of movement? If the body is in equilibrium, then your clockwise movements becomes equal to anti-clockwise movement. That what's your principle of movement says. So now see the numericals. The first numerical is the force of 16 Newton acts on a rigid body. The perpendicular distance between the force and the turning point. Turning point means your pivoted point. So the perpendicular distance between the force and the pivoted point. Actually, we require the perpendicular distance between the force and the pivoted point in order to calculate the moment of force. So we know that the moment of force formula is what? Formula is force into the perpendicular distance. Yes, perpendicular distance between the force and the pivoted point, right? So the force is given how much? 16, and the perpendicular distance from the pivoted point is given how much? 400 centimeter. But the just we have to do the question in SI system only. So here the force is how much? 16 Newton, but the perpendicular distance is how much? The 400 centimeter. That I need to convert into meter. That is what? 4 meter. So into 4, that is what? 64, and the unit for the moment of force is Newton meter. So here the force of 525 Newton produces a moment of force is this. So this is what? The moment of force is given. This is force. Force is how much? 525 Newton. The moment of force is how much? The moment of force here is 420 Newton meter. You have to find here the perpendicular distance between the axis of rotation and the line of action of force. So that what you just have to find here. So we know the moment of force is what? Moment of force is force into perpendicular distance. So here you have to find the perpendicular distance. So force is 240 divided by moment of force is 420 divided by 525 is equal to perpendicular distance. So if you divide this, you will get 0.8 meter. That is what your perpendicular distance. So it is 525. So 0. So just try to understand this question. This is very important question. We'll do more questions from the same topic in our next episode. But first, try to understand the meaning of this question. That is very important thing to understand. So we have a uniform meter scale. We have a uniform meter scale. It is balanced at 40 centimeter mark. Balance at 40 centimeter mark means this is the point of equilibrium where the body is balanced at this point. And we have to calculate the weight of the meter scale. Since it is a meter scale, so whenever the meter scale is uniform, so where the weight resides, that is exactly at the midpoint. So since the meter scale is uniform, so its weight is acts at 50 centimeter mark. So here it is 50 centimeter mark where the weight of the body resides. So we have to calculate actually this weight. Except this, what is according to question that weight is 25 GF and 10 GF. There are two more weight. Except this weight, there are two more weight, 20, 25 GF and 10 GF. 25 GF is marked at, this is 25 GF, that is marked at 5 centimeter mark, and the other weight is 75 at marked at 75 centimeter, that is nothing but 10 GF. So you just suppose what you have learned from the today's topic. This is the axis of rotation. So you need what? The perpendicular. You have here the three forces. This is your F1, this is suppose your F2, this is your F3. You have three forces. For this force, what is the perpendicular distance? Yes, tell me what is the perpendicular distance for this force. For this force, this is the perpendicular distance, right? Because we have to consider the perpendicular distance from the axis of rotation. And the body which is balanced at this point, this is the position of equilibrium, that is considered your axis of rotation. So this distance is how much? 35 centimeter. For this force, yes, tell me what is the perpendicular distance. Because to calculate moment of force, we again required force and perpendicular distance, right? So for this force, what is the perpendicular distance? Right, 10 centimeter. Okay. For this force, what is the perpendicular distance? The perpendicular distance is always taken from the axis of rotation. That is how much? Yes, you can calculate very fast. 40, 75 minus 40, that is how much? 35 centimeter. Now you have the three forces and you have the perpendicular distance also with respect to all the forces. So you just have to calculate the moments, clockwise movement, anti-clockwise movement, and make them equal, because at this point the body is in state of equilibrium. So what now I have to do? Now your question becomes too easy, right? So just calculate first the movement from here. This is the direction that I am indicating, that signify anti-clockwise movement, right? And here for this body and for this body, clockwise movement because our clocks goes like that, right? Yes. So now, first we need to calculate anti-clock. Otherwise, you can even calculate clockwise movement for that is not the issue. So, anti-clockwise movement, right, is what? Force into perpendicular distance. Force is this and perpendicular distance is that for this. So, it is 25 into 35, right? That will, if you multiply this, you will get how much? 875, right? Now, clockwise movements. So, you have two forces to calculate for clockwise movement. First is W into 10 plus, right. Next is 10 into 35. So, this is what your 10W plus 350, that is what your clockwise movement. So, then the body is balanced at 40 centimeter mark. So, you can say according to principle of movement, clockwise movement is equal to anti-clockwise movement. That is what you have learned in the principle of movement, right? So, what is clockwise movement? 10W plus 350 equal to 875, right? Now, 10W is equal to 875 minus 350. If you will subtract, then how much you got? 10W will be equal to how much? 525, and W will be 525 by 10, which is 52.5. What is the unit for W? Since the unit for these forces are in CGS system, so the unit of weight that you got in also GF, because we have not changed any of the unit, we have taken on that system only. So the answer, the force that you will come is also on in GF. So that is your answer, 52.5. GF will be your weight of the meter scale. So now we have done the concept of moment of force with the various applications and the numerical problem. So in the next episode, we'll go for more numerical problem on the topic, the moment of force and the principle of moment of force. That will be very useful for your board exams. So keep practicing.